Okay, these are notes 1.2. We're going to work with set builder notation and interval notation first, and talk about domain range functions and those sort of things. Okay, so this is called set builder notation. This says these are brackets for saying it's a set. So it says x. This line means such that. So x such that x is greater than, or not or equal to, but just greater than -2. So -2, it's not or equal to, so it's an open circle. And these here are the numbers that are greater than -2. Another way to say that is this. Okay, in interval notation, we use this bracket for this and this. Whenever we have the open circle, we're going to use this bracket when it is or equal to. So, yeah, bracket versus parenthesis, the equal to versus not equal to. Okay, so here's some examples. So we have all the numbers between 2 and 8, including 2 and 8. So in set notation, we would say x such that x is greater than or equal to 2, and x is less than or equal to 8, end brackets. In interval notation, since it's or equal to, it's between 2 and 8 is also or equal to. Okay, now these are open circles, not or equal to, so we have x such that x is greater than 3, x is less than 10. And since it's not or equal to, we're going to put the parentheses instead of the brackets between 3 and 10. We're going to use this interval notation a lot more because it's a lot easier to write. Okay, for this one, we have x such that x is greater than -2 and less than or equal to 5. The brackets just kind of put things there. Don't have to look too pretty. So with the -2, it's going to be the parentheses, and since this is or equal to, we're going to have the bracket. Okay. Number 4, same sort of idea. Okay, we're going to have x such that x is greater than or equal to -10. So or equal to is -10, and then less than 0. So parentheses with that one. Okay, x such that x. Well, really there isn't any upper bounds. We're just going to say x such that x is greater than -6. So if we're looking at this, we're going from -6, parentheses, because it's not or equal to, and we're going through infinity. With infinity, we're always going to use the parentheses. So with infinity, always parentheses. Okay? I forgot to tell you that here, but yes, same sort of idea there. Okay, number 6. So it's less than or equal to 2. So we can say, put the brackets there. X such that x is less than or equal to -2. So my lower bound here is -infinity. And we always use the parentheses for -infinity. And upper bound is -2, and it is or equal to. Okay, this is all real numbers. We can say x such that x is a set of, and this is a symbol we can use for all real numbers. Okay, so make an R with another little thing on the side there. So then that goes from -infinity to positive infinity, and we use parentheses for always with infinity. Okay, so that's our set builder and set notation and interval notation. Okay, next topic is, you've done this many times back in Algebra 1 and Algebra 2. A relation is just a set of ordered pairs. Okay, so for example, it's a set of like 1, 2, and 3, 4, etc. Okay, the domain are the x values, or the input, and the range are the y values, or the output. Okay, so the input here would be the 1 and the 3. The range of the y values would be the 2 and the 4. Okay, so if you're looking at this function here, try and do it yourself. Pause it and do it yourself. Okay, the domain are -2, -1, 0, 1, and -2. Now, since -2 is already included, I don't want to include it again. So that's my domain. My range. Okay, and also you should technically, I probably wouldn't take count all for this, but you should put them in order. So if you look at your range, are 0, 1, 2, and 2. So 0, 1, and 2. Once again, if there's repeats, you don't need to write it more than once. Okay, if you look at this one, our domain here, I'm going to put my, you could do either set notation or interval. I'm going to put it in interval. So my domain goes from -3 to 3. I don't have any values less than this or greater than this, but I do have all these values in between here somewhere on this line. So my domain is between -3 and 3. So it's including -3. So do I use the parenthesis or bracket? Okay, use a bracket between -3 and 3 because it's or equal to those. Range, I'm looking at the y values. Y goes up to 6. Okay, and then we have all these values here, and it goes all the way down to -6, but nothing below -6. So it's all values between 6 and -6. And since it includes them, we use the brackets. Okay, this one here, straight line, arrow meaning keeps going on forever and ever. Domain, all these x values, all these points here have x values that will keep going to infinity, and all these x values down here will keep going to negative infinity. So every x, so it's all real numbers. So we can write that as from negative infinity to positive infinity. The range, okay, so y values, okay, these y's just keep increasing up to infinity. These y's keep decreasing all the way to negative infinity. So once again, negative infinity to positive infinity. Okay, this one here, domain. Okay, so this x is at 2, but I also have an x at 3 and at 4 and at 5 and at 6 and at 7 and at 8, and it keeps going to infinity. And the same thing down here. The x's keep going down to negative infinity. So my domain is from negative infinity to positive infinity. My range, okay, so now my range, my y, goes here to -1. I don't have any more values beyond that. But I do have y values up here. So from -1 to infinity. So I'm going to write that, since it includes -1, use the bracket, all the way through infinity. Okay. So now we'll talk about, besides the domain range, we're talking about functions. A function is an ordered pair where, or is a relation where the domain, or the x value, corresponds to exactly one y value. Okay? I kind of think of it as this. If I have somebody x, okay, x is some person, they can only date one person. They can't date more than one person. Would not be a functional relationship there. So if we think about this right here, each x, okay, so the 1 is dating or corresponds to the 2. The 1 does not correspond to anything else. The 3 only corresponds to the 4, and the 5 only corresponds to the 6. So yes, that is a function. Okay, whereas 13 here, you see 1 corresponds to 1, but 1 also corresponds to 2. So I have an x of a 1 corresponding to both a 1 and a 2, which makes that not a function. Okay, here, looking at the x's, every x only corresponds to one y. Now this one's a little different. Notice that each y does correspond to two different ones, but that doesn't matter. It only has to be the x to correspond to one y. So yes, this is a function. Okay, so here we have x and y such that it's part of this line. If you remember how we graph this line, our y-intercept is at -2, and our slope is 1. We have this line here like this. Okay. Now, you can also give that in Desmos right now if you want to as well, if you don't remember how to graph. But if you look at this, remember we use something called the vertical line test. Basically, if I can draw a vertical line and it only goes through my equation one time, then yes, it is a function. Okay. Whereas down here, if you look at this one, if I draw a vertical line right here, let's say that's an x of 1. This point here would have an x of 1, and that point there would have an x of 1. Therefore, that's not function because the x of a 1 corresponds to 2 different y values there. This one here, I draw vertical lines, I only hit once, so yes, it is a function. Okay. Now, one way to graph things is to make a table of values. So if you look at this example right here, I just pick some random x's and we're going to plug them in. So 2 times -1 is -2, minus 5 is -7. Plug in a 0, 2 times 0, 0 minus 5 is -5. Plug in a 1, -3, plug in a 2, -1, and 3 is a 1. Okay? So we could also think of this as f of x is equal to 2x minus 5. And what we're basically finding is f of -1. F of -1 was equal to -7. F of 0 was -5, etc. Okay? So basically, we just want to graph them. So -1, -7's right there. 0, -5, 1, -3, 2, -1, 3, 1. And you can see I have my linear line there. Okay. Okay. And the last problem we're going to do here in 1-2. Here's the equation used to convert Celsius to Fahrenheit. So I have a friend in Canada. Every time he talks to me, he's telling me what the degrees are in Celsius. That doesn't mean much to me because I always use Fahrenheit. So I have to convert. So my Fahrenheit is equal to f of 37. I just plug in 37. So I have 9/5 times 37 plus 32. Use Desmos for your brain or a calculator or whatever. And that is 98.6 degrees Fahrenheit. So does that look familiar? Especially in these COVID days? Yep, it's human body temperature. So there, when they're looking at temperature, and a body temperature that is not a fever is 37 degrees, whereas we use the 98.6. Okay, f of 0. So if I want to know Celsius of 0 degrees, I can find f of 0, plug in the 0 here, and I have 32. And what is 32 degrees Fahrenheit? It's our freezing point. So water freezes in Celsius at 0 degrees. Okay, and -40, if I want to find f of -40, okay, plug in -40 there, and that comes up to be, oh, interesting, -40. So -40 is where the two scales meet and are the same value. And it actually is, in Canada where my friend lives, actually the degree of where they call off school as well if it's -40 degrees, which happens to them sometimes anyway. Interesting. Yeah, if you have any questions, let me know. Thanks.